Bismillah ar-Rahman ar-Rahim. We'll start now 9.7. As I said, I will connect it with 9.10. Let us see what we have. We're talking about Taylor polynomials and approximation in 9.7 and Taylor and Maclaurin series in 9.10. Okay. So if I have a function, what's mainly the idea? I want to approximate any function by the polynomials. So if I want to find the first degree polynomial, whose what? Whose value and slope agree with so I want the polynomial and the function both agree about their value. I'm choosing x equals 0 at x equals 0, and also the slope at x equals 0, they both agree. So I need P1 at 0 equal f at 0, and P1 prime at 0 is equal to f prime at 0. That's what I'm looking for. By the way, this will be the answer. So, okay. Now, so it means I need to find A0 and A1 where P1 satisfy these two conditions. Okay. So it will be f prime. X, what will be P1 prime? It will be A1. Okay. So P1 at 0 equal f of 0. This implies what? This implies P1 at 0. I have A0, f at 0, 1. Okay. Now P1 prime at 0 equal f prime at 0. So P1 prime at x, so at 0 it will be A1. F prime at 0 it will be 1. So what will be P1 of x? A0 is 1, A1 is x, is 1. So I have 1 plus x. So this polynomial agreed with this function at x equals 0 and also at the derivative or the slope. Okay. According to that, now we'll define what's called Taylor polynomial and int Maclaurin polynomial. Assume f has n derivative at the value c, then this polynomial, f of c plus f prime at c, x minus c. Look at this, f double prime of c over 2 factorial. Then the next one, f triple prime at c over 3 factorial, x minus c to the power 3, and so on. So this polynomial of degree n, so we call it, because of that we call it nth Taylor polynomial, is called the nth Taylor polynomial of f. If c equals 0, then we call it nth Maclaurin polynomial for f. In case of e to the power x, what will happen? My Pn of x will be what? Okay. Let me do that for e to the power x to show you how to apply the formula. Now, I want to check nth Maclaurin polynomial for f of x, e to the power x. Okay. The formula. What is the formula? Pn of x will be f at 0, f prime at 0, x plus f double prime at 0 over 2 factorial x squared plus the n derivative at 0 over n factorial x to the power n. That will be my formula. Okay. Now, this is my f of x. What is f prime? e to the power x, second derivative, e to the power x, the n derivative, very clear, e to the power x. Great. So, what will be f at 0? I'm doing it in too much detail. F of 0 is 1. No, this is f at 0. F prime at 0, also 1. F double prime at 0, also 1. The nth, the n derivative at 0, also 1. So, Pn of x will be what? F of 0, 1. This is 1 times x plus x squared over 2 factorial plus x cubed over 3 factorial plus this one will be what? The n derivative is 1, so it's x to the power n over n factorial. And that's what they write there. Where is it? Yeah, this is what I have here. Okay. So what's going on? I'm trying to approximate the function using the polynomials. I'm trying to approximate the function here. I'm trying to approximate the function using these polynomials. Okay. And it's better as n increased. If I have higher degree Taylor polynomial, then the approximation will be better. And also, if I check the value near C, either C equals 0 or not equal to 0. Okay. Find the Taylor polynomial for this one. B0, B1, B2, B3 for which function? Ln x. Okay, so this is my function. Ln x. What is f prime? 1 over x. What is f double prime? Minus 1 over x squared. What is f third derivative? Minus 2 over x cubed. Fourth derivative, because I need p4. So I need the fourth derivative. Will be what? Oops. This is minus 2x is minus 3. So that will be 6. X is minus 4. Okay. Now what will happen? Okay, now C is what? 1 here. What is f at 1? It will be 0. What is f prime at 1? It will be 1. What is f double prime at 1? Minus 1. What is third derivative at 1? Minus 2. What is fourth derivative at 1? That will be 6. Okay, so P0 of x will be f at 1. I like the formula. So this is P0. This is P1. This is P2, and so on. Okay. Is equal P0 of 1, P0 of x. That will be f at 0, f of 1, which is 0. P2 of x. P1 of x, sorry. P1 of x will be f of 1 plus f prime at 1 times x. And that will be, this is 0. That will be x. Oh, sorry. I'm doing it with c equal 1. So I need x minus c. Let me write the formula here. Pn of x. I'll try to squeeze the formula here. Pn of x. That will be f of c plus f prime of c times x minus c plus f double prime c over 2 factorial x minus c squared, and so on. Okay, until the nth derivative. Okay, now this is x minus 1, c equal 1, so x minus 1. So that give me what? This is 1, give me x minus 1. P2 of x, that will be f of 1 plus f prime of 1 times x minus 1 plus f double prime at 1 over 2 factorial x minus 1 square. So that will be what? X minus 1. F double prime is minus 1, so that will be minus 1 over 2 x minus 1 square. Now what is P3 of x? It will be f of 1. It will be f of 1 plus f prime at 1 x minus 1 plus f double prime at 1 over 2 factorial x minus 1 square plus triple at 1 over 3 factorial x minus 3 cubed. And that will be what? X minus 1. Everything is minus 1. Huh? This is 1. Since my c is 1. Okay. That will be what? 0. I have x minus 1 minus half x minus 1 square. Now what is this? 1 over 6. And this is minus 2 over 6. No, sorry. This is plus. Yeah, this is plus. This is minus. So this is plus. So 2 over 6 plus 1 over 3 x minus 1 cubed. The fourth polynomial. It will be f of 1 plus f prime at 1 x minus 1 plus f double prime at 1 2 factorial x minus 1 square plus the third derivative at 1 plus the fourth derivative at 1. Okay, so the same thing as this one. Okay, now we'll come to the last one. 1 over 4 factorial. 4 factorial, which is 4 times 3 times 2, 24. And what is f of 4? Is minus 6. Huh? That is minus 6. So minus 6 over 24, this is minus 1 over 4 x minus 1 to the power 4. And that will be P4. Yeah, that will be P4 for x. Now, for your information, now if I take P4 at 1.1, I'm getting this. Where ln of 1.1 is this. Look at these two, they're almost the same. Up to this, up to 4 digits, they are the same. Okay, or up to 3, okay. Find the Maclaurin polynomial for this function, cosine x. Yeah. Okay, I want Maclaurin. And it means what? C equal to what? 0. Okay, so I have f of x equal cosine x. F prime equal minus sine. F double prime equal minus cosine. Third, that will be sine x. Fourth, that will be cosine x. Fifth, that will be minus sine x. Sixth, that will be minus cosine x. What I care about, since I need the Maclaurin, I need C to be what? 0. So what will be f at 0? 1. F prime at 0, 0. F double prime at 0, minus 1. F triple prime at 0, 0. 4 derivative at 0, 1. Fifth derivative at 0, 0. Sixth derivative at 0, minus 1. Okay. Now what will be P0 of x? That will be f at 0, which is 1. P1 of x, that will be f of 0. I don't want to, I want 2. P2 of x, I'll tell you why. Because f prime at 0, x plus f double prime at 0 over 2 factorial x squared. Because this is 0. So no need to worry about. So this is, will be half. F prime at 0 is minus, so 1 factorial x squared. P4 of x, let me do it right away. I have f of 0. F of 0 is 1. F prime at 0, gone. Second derivative, give me 1 over 2 factorial x squared. Third derivative, 0. Ignore it. Fourth derivative, I want 1 over 4 factorial x to the power 4. What is B6 of x? It will be this one. Now, when it comes to the fifth derivative, this is 0, gone. Sixth derivative is minus. So minus 1 over 6 factorial x to the power 6. Yeah. I will leave it for you to approximate this. You need the calculator to do that. Do it through the calculator, see what will happen. So you want to check P6 at 0.1 as an approximation of f of 0.1. See what is the difference. Okay. Now find the third Taylor polynomial. You want P3 of x. What is C? Pi over 6. Okay, so I need to find f. First derivative. Second derivative. Third derivative. I substitute. I substitute that what? I have f. C is what? Pi over 6. That will be half. F prime at pi over 6. That will be square root 3 over 2. F double prime at pi over 6. That will be minus half. Third derivative at pi over 6 minus square root 3 over 2. So what is B3 of x? It will be f of c plus f prime at c. Let me write the formula. By the way, this is mainly the section, huh? So f of c, half. F prime of c, x, what is c? Pi over 6. This one minus 1 over 2 factorial x minus pi over 6 square. This one minus also minus square root 3 over 2, 3 factorial. I know C. Okay. So that will be P3 of x. As a Taylor with C equal pi over 6. Use the fourth Maclaurin series to approximate this. Okay. I want to approximate this ln 1.1. But I want what? Maclaurin. So my C is 0. So now if I use ln x, I cannot. For C equals 0. Okay. So what I will choose, Also, I want to choose something to get a good approximation. So something not far from this one at c equals 0. So I have len 1 plus x. This is my function. Okay, so this is the function which I will use. Why? Because I want Maclaurin, so c equals 0. That will work. So I have len 1, which is not far from len 1.1. So it will be a good approximation. I mean, 1 is not far from 1.1, so it will be a good approximation. If you remember, we said we want the values close to c. So c equals 0, then 1 will be not 1 is not far from 1.1. Okay, now I need what? The fourth. So I need the fourth derivative. G prime 1 over 1 plus x. G double prime. Yeah, let me do it like this. Minus 1 plus x to the power minus 2. G triple, G third derivative. That will be 2. 1 plus x to the power minus 3 plus, G fourth. At x, that will be minus 6. Okay, I want to do it at what? At c equals 0. So G prime, first, G at 0, that is will be then 1, which is 0. G prime at 0, that is 1. G double prime at 0, minus 1. G third derivative at 0, this is 2. G fourth at 0, minus 6. So P 4 of x, that will be what? G at 0, G at 0, plus G prime at 0, G double prime of 0 over 2 factorial, x squared. Yeah, let me give it more space. Let me put it here. P 4 of x. That will be G at 0 plus G prime at 0 x plus G prime at 0, G double prime at 0 over 2 factorial x squared plus third at 0 over 3 factorial x cubed plus fourth at 0 over 4 factorial x to the power 4. Okay. G at 0 is 0, not 1. What is this? Len 1, which is 0. Len 1, which is 0. So I have 0. G prime at 0, 1. So that will be x. G double prime minus 1 over 2 x squared. G triple, it's 2 over 3 factorial. So 2, 3 factorial, 2 times 3. So it will be 1 over 3. Plus, plus 1 over 3 x cubed. This one minus 6 over 4 factorial. So for sure, this will be minus 1 over 4 x to the power. That will be the polynomial. What they want, you want me to approximate len 1.1, which is I can make it len 1 plus 0.1, because I'm using this function, len 1 plus x. So my x is 0.1. So this is approximated with B4 at 0.1. Because I'm approximating this function. What I'm getting, len 1 plus x, I can approximate it, use Pn of x. So I choose x to be 0.1, which is this value, which is not far from len 1.1. Yeah, we did len 1.1 before. Yeah, 0.0453 1, 0, 2. Yeah, almost the same value. Okay. Yeah, that's mainly the section, by the way. Okay. Finding a first degree polynomial. Approximation, find the first degree polynomial P1 whose value and slope agree at x equals c. So I need P1. What is P1 of x? It will be A0, not A0, f of 0 plus f prime at 0, not c, f of c, sorry, f prime at c x minus c. So this is c and this is my f. So it will be f prime. This x is what? 6x is minus 1 over 3. So f prime will be minus 2x is minus 4 over 3. Correct? Yeah. So P1 of x. So what is f of c? F of c will be 6, 8 to the power minus 1 over 3. Cube root of 8 in the denominator, 6 over 2, that will be 3. Yeah. Cube root of 3. Cube root of 8, this is 2. So that will be 3. What is this? Find the first degree polynomial whose value and slope agree with the value and slope of f and c. Yeah. So cube root of 8 is 2. So you have 6 over. Yeah, that will be 3. Okay, leave it. Now f prime at c will be what? F prime at c, I will substitute here. So that will be minus 2 times 8 to the power minus 4 over 3. That will be minus 2 times cube root of 8 is 2, 2 to the power minus 4. So I have what? Minus 2 over 16, which is minus 1 over 8. Okay, so this is f prime at 6. Huh? At c where c equals 6. C equal 8, sorry. That will be at 8. So P1 of x will be f at 8 plus f prime at 8, x minus 8. Yeah, let us put the numbers. F at 8, we say what? 3. F prime at 8 minus 1 over 8 times x minus 8. That will be 3 minus 1 over 8x plus 1, which is 4 minus 1 over 8x. Okay, so that will be 9.7, which is, I think, very clear. Just you have a formula, you just apply. Just you need to find the derivative. Okay, now we'll go to 9.10. What is we have in 9.10? Now, what will happen to the series? What will happen to this Taylor polynomial or Maclaurin polynomial? It will be a series now. I continue. I will not stop at n. I will continue. So I'll have a series. So f can be represented by a series now. Where what is the n derivative? What is the an? So power series. So I want to make f of x as summation an x minus c to the power n. What will be this an? An will be the n derivative at c over n factorial, which is the same like we did here. If you notice the an is this is the an. But now I continue. I will not stop at n. So I have a series now. Okay. The coefficient of the Taylor polynomials. So because of that, we call it Taylor series. So this is the Taylor and Maclaurin series. They call it Taylor series. But this is an x minus c to the power n. is the same as the Taylor polynomial, but I expand now the n goes to infinity. Okay. Maclaurin, just I will change the c to 0. So it will be this one. Or in other words, this is the Taylor. This is the Taylor series with the function f at a, centered at a, or about a. Maclaurin, I have make a equal what? 0. So I have this one, which is the same as the polynomial, but where n goes to infinity. Find the Maclaurin series for this function, e to the power x. Yes. I know if f of x equal e to the power x now the catch is how to find the n derivative, because I'm going to write it as a series. So f prime e to the power x, second e to the power x, the n derivative also e to the power x. Okay, if I want to find the Maclaurin, so I will make c equal what? 0. So it will be f at 0, 1, everything is 1. The n derivative at 0, also it's 1. So it will be the series, which this one, we say f of x will be equal summation n equals 0 to infinity. The n derivative at 0 over n factorial x to the power n. What's the n derivative at 0? It's 1. So that will be summation n equals 0 to infinity. This is 1 over n factorial x to the power n, which is this one, which I can write it this way. What will be the convergence of this? If I do the ratio test, limit an plus 1 over an as n goes to infinity, that will be what? Limit x to the power n plus 1 over n plus 1 factorial reciprocal of this. That give me limit n goes to infinity of what? X over n plus 1, which is equal to 0, less than 1. So this series converges for all x. It means this is equal to this for all x. So if you want to approximate e, I'll write it instead of x, I'll write 1. So if this is e to the power x, so e to the power 1 would be summation n equals 0 to infinity. 1 to the power n. 1 to the power n is 1. It's 1 over n factorial. So this is 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial, and so on. So you want to approximate E, I can, for example, I take the first 4 terms, 10 terms, 20 terms, I can approximate E. As I increase the terms, I'm getting a good result or a good approximation. Yeah. Now, if we want to do the Taylor series for this function, e to the power x at a equal to, then I will stop, because I don't want to have a long video. Okay, same thing. Now I need to find f prime until I get the n derivative, which is ax. So it will be f now a 2, c equal to f of 2 a square, f prime at 2 a square also, the n derivative at 2 also a square. So it will be the polynomial e to the power x will be equals summation n equals 0 to infinity. Look at the formula. This is the formula. I put a or c, that will not make a difference. Or let me write it using this series. So it will be the summation, the n derivative at a, I'm using a here, over n factorial x minus a to the power n, which is this series, n equals 0 to infinity. But then derivative at 2, a is 2. calculate the n derivative. Let me write it. X minus 2 to the power n. So that will be summation n equals 0 to infinity e square over n factorial x minus 2 to the power n. You can do the ratio test where you will see it will converge for all x. And this is so the radius is what? It's infinity. Let me stop the recording. Yeah, this is mainly what we have in these two sections. Now we'll do more examples and we'll talk more about this, the series, Taylor and Maclaurin series. Yeah. I don't like to have long video, so I'll stop the recording. Thank you.